Alright, hello everybody. We're going to go ahead and start our lesson on variables and relationships. So first thing you guys need to do is have this video open in one tab, and then go ahead and open up another tab and go to joinpd.com, and you'll type in this join code up on the top right. That's HSBTJ. So as we go through this video, I'm going to ask that you go through the presentation in your other tab. Because it will ask you to answer some questions and interact with the presentation there as you go along. And then I'll be, while you're watching the video, giving you feedback as you go along. So very important that you do both at the same time. Okay, so let's just go ahead and jump right in. So what I want you to do is pause the video and go ahead and complete the bell ringer in Canvas. So once you're finished with the bell ringer, you can come back to this video, but go ahead and complete that. Okay, and once you're done with that, then go ahead and get out paper and pencil just to jot down some notes, any questions that you might have, and then that way you can work example problems with us as we go along too. So that's our preparation for this lesson, okay? Alright, so we are in Module 0, Measurement. This is, I guess, our first official lesson outside of like lab safety and lab equipment that we've done so far. And we are going to be in Section 1, which is Variables and Relationships for this lesson. Okay. So our objectives for today, we're going to identify variables in an experiment as either dependent or independent variables, and then we're going to characterize a relationship between variables as either directly proportional or inversely proportional. So those are our two objectives for today. Okay, here's our new vocab, so you can read through these. We got variable, experiment, independent and dependent variables, directly, inversely proportional, chemistry, and then quantitative and qualitative data. And then also in every lesson, I'm going to have this main idea section. This is kind of where I'm going to summarize the main point of the lesson, and you can come down here and jot this down after every lesson if you like, just so that you have a nice summary of the lesson that we covered for today. Alright, so next. So I do want to start off just by talking about what is chemistry, because I don't feel like we've addressed that yet. So basically, everything in the universe, all of the stuff in the universe, is made from building blocks that are formed in the stars. Okay? And these building blocks, and then everything made from them, are called matter. So you guys know, I'm sure you've heard the term matter before. Matter is anything that has mass and takes up space. So that's pretty much anything that exists that you can touch, see, feel, and interact with in the universe. Okay? And then chemistry is just the study of that matter and the changes that it undergoes. So we're studying all matter, how matter interacts with each other, and all of those things in chemistry. Okay? I do have a little video here. I'm not going to play the video during this video, but I will go ahead and tell you to pause the video, go into your other tab where you have the presentation going, and play the video there, and then come back to this one once you're finished. Okay, so go ahead and do that. I'm going to move on. Alright, so in chemistry we do a lot of experiments, and whenever we do experiments we make observations and collect data. So an observation is just the act of gathering information. And information can be anything. It can be a measurement, like how tall are you, how much do you weigh, how long is the room, or it can be, you know, what color is the wall, or something like that. So any of those is a piece of information. Use observations to collect that information. Okay, and then there's two types of data. There's qualitative data, which is just describing qualities of an object. So for example, its color, its smell, its shape, or some other physical characteristic. And you collect qualitative data by using your senses. So you're looking at something, describing it, you're touching something, you're listening to it, you're using any of your senses just to make a description about the object that you're looking at, and that's qualitative data. The next type is quantitative data. And so quantitative has the root word quantity, which just means it's a number. And so quantitative data is obtained from numerical observations or measurements that describe how much, how little, how big, or how fast. So if I take your temperature every morning as you walk into school, which is what we're now doing at PHS, that's an example of quantitative data because there's a number attached to it. Okay? Alright, so on your other tab where you have the presentation going, I want you to go ahead and pause this video and answer these two questions. There's a text box for you to type in, so go ahead and pause, answer those questions, and I'll be monitoring on my device in real time, giving you feedback as you go. So it's really important that you do this step. So come back and play once you're finished with that. And I'm going to go ahead and move on. Okay. Whenever we do experiments, we make hypotheses, and so a hypothesis is a tentative explanation. That tentative just means that it could change, but that's the explanation that we're going with at this moment for what has been observed. That's a hypothesis. And an experiment is just a set of controlled observations that test that hypothesis. So we want to test something, we come up with an explanation, and then we do an experiment to see if our explanation is true or not. And if it is, then we support it with the data that we found. And if it's not, we go back and we form a new hypothesis. Okay. All right, a variable is a quantity or condition that can have more than one value. So variable means it could change, like x in algebra class, or y is a variable. It can take on any value that you put into it. So in science, an independent variable is the variable that I change, or that as the scientist, this is what I plan to change to see how other things respond to it. So the independent, you can remember this because it starts with an I, is the variable that I change. Okay? And then the dependent variable is the variable that changes in response to the change in the independent variable. So for example, if I'm seeing how fertilizers affect plant growth, I can change what type of fertilizer I use. That's the independent variable. And then the dependent variable would be how tall the plants grow, or how many tomatoes I get in my plant, or whatever I'm looking at. That's the dependent variable that changes because I changed something else, if that makes sense. Okay? All right. Scientists look for relationships between variables, and they can do this by putting the data in a table or by graphing the data. So down here I've got a little grid. On the y-axis, the vertical axis, we graph our dependent variable, and then the x-axis or the horizontal axis, we graph our independent variable. That's the one that we change. Okay? All right, so scientists look for relationships, and we do that by looking at a table or a graph. Okay, and then there's the information that I just talked about with the independent variable or the dependent variable. Okay, here's another question that I want you to answer in your slide. So go ahead and pause this video, and I want you to drag your dot to the spot on the grid where the independent variable is biggest and the dependent variable is smallest. Remember that the independent variable is on the x, the dependent variable is on the y. So drag your dot to wherever spot on the graph you think the dependent is smallest and the independent is biggest. Go ahead and pause, do that. I'll give you some feedback. Come back to this video when you're done. I'm going to go ahead and move on. Okay, so scientists look for relationships by seeing how variables are changing. So variables are getting bigger or increasing as you move to the right on the x-axis or as you move up on the y-axis. Okay, and then of course they're getting smaller if you move the opposite direction. So if you move to the left on the x-axis or as you move down on the y-axis. Okay. All right, so now I just want you to kind of reflect on the things that we've talked about. If you're okay with everything we've talked about so far, awesome. If you think that you're confused and you need a little help, jot down some questions that you may have and then come back into the Teams meeting and ask those questions, okay? But you can go ahead and drag your dot to whichever spot here that you're feeling and pause the video, do that, and then come back, and I'll take a look and answer any questions as you come back in the meeting, okay? If you had your dot in the yellow or red, what are some questions that you have? Go ahead and write those down on this slide. So you can go ahead and pause and do that if you feel the need. And I'm going to go ahead and move on again. Alright, so there are two types of relationships that we're going to look at between variables, and those are directly proportional and inversely proportional. Okay, so directly proportional means that as the independent variable increases, the dependent variable also increases at the same rate. Means like, what an example of that might be, if you work more hours, then you're going to earn more money. So the amount of money that you earn is directly proportional to the amount of hours that you work at your job. Okay, and then inversely proportional means as the independent variable increases, the dependent variable decreases. So it does the opposite. Okay, so an example of this might be as I travel at a higher rate of speed, then the time that it takes to get to my destination decreases. So as speed increases, the time that it takes for me to get there decreases. Those are inversely proportional. Okay? All right, so directly proportional, it can be represented by a mathematical equation, y equals kx, where x is my independent variable, y is my dependent variable, and then k is just a number. It can be 1, 2, 3, 4, you name it. Okay, and it just tells you how steep the line is. It'll be the slope of your line. Okay, and then this is the example that I just gave you. So how much money you earn in a day is directly proportional to how many hours you work. If you earn $10 an hour and you worked 8 hours, then you would figure out your earnings by multiplying your constant of proportionality, 10, by the number of hours you worked, 8, and then you'll get $80. So that's a relationship that is directly proportional. And if I graphed that, it would look just like this. So on a graph, if you see, remember my independent variable gets bigger as I go to the right, and my dependent variable gets bigger as I go up. So these are getting bigger at the same time. That means that they're directly proportional. As I go further to the right, I also go further up on my graph. Okay? Inversely proportional is the opposite of that. So y is inversely proportional to x is the same thing as saying y is directly proportional to 1 over x. So if I write that equation out, it's going to be y equals k times 1 over x. Or if I simplify it, y equals k over x, where y is my dependent, x is my independent, and then k is my constant of proportionality, where it's just some number. Okay, and then my example there is travel time is inversely proportional to how fast you travel. So you travel 100 miles and you want to know how long it takes. You would just divide your distance by your speed, and you would get your traveling time of, in this case, 2 hours. Okay, and then the graph of that would look like kind of a curve. This should be more curved, but the software that I used didn't make it curved. But it would be a nice smooth curve, starting real steep, going towards the x-axis, and then it would kind of tail off here at the end. And that's what an inversely proportional graph looks like. Okay. Here's a question that I want you to answer in your other tab. So all of the stuff in the universe is made from blank. So go ahead and take the time on your presentation to answer that. I'll give you your feedback. The answer is on the next slide, so go ahead and pause the video and do that. Come back whenever you've answered it. Okay, and if you said B, matter, then awesome job, you got that one correct. If you said something else, maybe go back and review the beginning of the video where we talked about what is chemistry. Okay. All right, and then the next one, I've got one more question for you. So quantitative data describes observations that are blank. Go ahead and pause and answer that question. The answer is on the next slide, so pause, answer, and then come back to see if you were correct. Okay, and then that one is A, numerical. So if you said A, awesome job. Remember that quantitative has the root word quantity, which is a number. So quantitative data is any data that is numerical. Okay? All right, so that is it for this lesson. If you have any questions about today's lesson, you can go ahead and ask them on this slide. Going back to your other tab, you can ask any further questions that you have, and I'll respond, give you feedback. What I want you to do now, go ahead and complete the exit ticket in Canvas, and then go ahead and complete the assignment on Canvas. It is the 0.3.1 Variables and Relationships assignment. I will be in Microsoft Teams until the bell rings at 10 o'clock. So if you have any questions about any of this, the exit ticket, the assignment, the lesson in general, feel free to pop back in the Teams meeting and ask me any questions that you have. I will be here until the bell rings. Okay? Thank you guys for watching. I hope this made sense. And again, if you have any questions, please feel free to come in the Teams meeting and ask, or send me an email or a message on Remind. Thanks.